So we are starting our last unit of the year. There's only 3 sections on this one, and it's really quite easy. It's graph theory, but it's a different way of looking at graphs than I don't think you guys have looked at it this way before. Okay? So I want to give you guys some general definitions first, and then we will go from there. So first of all, a graph is really a finite set of points. And those points are called vertices. And line segments or curves called edges. That start and end at vertices. So vertices. Vertices are actually points. I alluded to that in the last definition. They're just points. And if you want to refer to it in the singular form, what is it called? Point. Nope. Oh yeah, points in singular form is point. But what is it? Vertices in singular. Vertex. Okay. So it's a vertex in singular form. Okay. An edge. An edge is a line segment or curve that start and end nope, at vertex or at vertices. The last one is a loop, and it's a special kind of edge. It is an edge, but it starts and ends. Starts and ends at the same vertex, right? So, taking all these little vocabulary terms, I wanted to show you on this one, okay? An edge can be any of these. It can be this curved line, it can be this loop, okay? And it could be a straight line. Any of those could be edges, okay? A vertex are any of those blue points. They're start and end points for edges. And then this right here is the only loop we have on this particular graph. Okay? It says not every point where 2 edges cross is a vertex. There's an example of that right here. Just because the 2 lines cross does not make it a vertex. It's not a beginning or an end point on this edge. Just happens to be where the paths cross. We want to talk about equivalent graphs next. They must have the same number of vertices connected to each other in the same way. The placement of the vertices and the shape of the edges are unimportant. So the scale is not important on these, and the shape is not important. You can have an equivalent graph as long as the connections are the same. Okay? So if you look up here, this graph that we drew up here, it's actually the word hornets. Okay? Now I'm going to draw the same equivalent graph down here below. And I know they're going to be equivalent because my edges will be, the connections will be the same. So starting at H, what are my edges coming out of H? What are they hooking into? R is one of them, so I can go ahead and draw an edge going to R. What's another one? T. And there's also another edge hooking into R, right? There's two of them. Okay, so now let's look at O. What comes out of O?
T.
Yep, one going to T, so I can, and one going directly to R itself. Okay, look at R. I already have the edges going to H and O. I still need one going to T. And also there's this loop coming out of R, so I can just put that right here. Okay. How about N? Yep, just T and E. So I can have one going to T and one going directly to E. How about E? Just T. We already got one going to N, right? And then we already have T taken care of by all the other ones.
Cool.
So this particular graph is equivalent to this one.
Oh, weird.
It looks totally different. But, and it's not even the same size. Okay? But what makes it equivalent are the connections, and the vertices are the same. Okay? So we have a checkpoint from the book that I want to show you. Here it is. And it says, explain why figures 15.4 A and B are equivalent graphs. Can you guys explain that? Why are they equivalent?
Because they have the same connections to the same.
Exactly. They are the exact same connections, the exact same vertices. So if you look at A has a connection here to B and to C. And over here, once again, A has a connection to B and C. Okay? You got to check them all. Make sure that they're the same. So B has a connection to A, obviously. It also has a connection to E, right here. It has a connection to D, right here. Okay, check D. D has a connection to C that we didn't check before, and to E. Yep. Yep, so they are definitely equivalent graphs. All right? So that's the first one we're to look at. And the second one, for checkpoint 2, I want to first look at this graph right here. There's an island here. And one of the things they want us to do is actually make a graph from a map. Okay? So basically, you're going to put like a point on the map simplifying like the center of that island. Oops, sorry about that. It happens every once in a while on this. I don't know why. It's annoying. And here's that. Okay, so we have our points. Now notice that Island A has quite a few bridges coming from it. Okay, so I could connect with right bank through this bridge and through this right here. And I can connect with left bank right here. All right. I can also connect right bank R to Island B through this bridge, A to B, and then L to B. So that's why they came up with this right here. Okay, same thing. But now you don't have the topography on the map. It's just a plain simple map. And then going from that, this is the actual graph. So this is the final product that they're wanting. Going from a map to a graph. Okay? So doing the same thing, looking at this particular checkpoint too. Notice that I put points on all the islands, and there's only one connection to North Metroville, and that's through Island A, going across the bridge there. And there's bridges in between A, B, and C. And then C to South Metroville, there's 2 bridges. So I connected those. So if I were to actually draw the graph for this, it's going to look the same way, but without that map in the background. Okay? So, that being the case, I now want to look at this map here. Okay? The western states.
Can you technically just draw a line through each border, basically?
Yeah. Yeah. On this one, they're wanting to just to look at the bordering relationships. If they do not border, they cannot connect. Okay?
Not the four corners spot where it was.
Yes, that's still, you can connect. Yeah, that's a good question. We'll talk about that in just a minute. So, on this one, we have WA and OR. I'm going to make vertices called that, just so we can remember what they are. And I'm going to put a circle around it, because that's going to be my vertex. So, WA, Washington has a vertex. OR has a vertex. California has a vertex. Nevada. Idaho. Montana. Wyoming. Utah. Colorado. Arizona. And New Mexico. Do I have them all? I think I do. Okay, so if I want to make a graph of this map, basically I'm going to make my vertexes, which I already have, and then I need to make my edges. And my edges are where they can connect a bordering state. So like Washington borders Oregon, and it borders Idaho. Does it border Montana? No, so I cannot make a connection between them, okay? So Oregon also borders Idaho, Nevada, and California. Well, Oregon does not border Utah or Wyoming. Okay. Okay, yep. Okay, so if you look at Idaho, yeah, Idaho also borders Montana, Wyoming, Utah, Nevada, Oregon, and Washington, which we already have. So that's what you basically need to do, is connect the borders. Montana connects with Wyoming also. Wyoming has already connected to 2, but I need to connect it to Utah and Colorado. California, I can connect with Nevada and to Arizona. Okay, Nevada connects to Utah. And now this last one's quite interesting, because you have this crossroads thing going on right here, right?
Isn't Nevada touching Arizona as well?
Yes, you're right. So I know all these 4 connect in a square, obviously. But you can also argue that you can step directly from Arizona into Colorado, can you not?
Yeah.
Without touching the other 2 states.
As well as the other way around.
So I can connect these 2 like this. But notice that this is not a vertex in the middle of them, and they just happen to be a crossroads.
Kind of like the one triangle.
Yep, right. Yep. Okay? So if you look further down on your page, or on the next page even, you have a map of the Northeast. I want you to do the exact same thing that we just did on your own, and we'll check it in a minute. Okay, so if you were to actually graph this here, notice that Maine only has 1 border, and that's New Hampshire. Okay. Massachusetts has a bunch. But one thing I noticed that I think a lot of people don't even realize is that New Jersey does not border Connecticut. That black line does not exist. Because honestly, there's just a little strip of land here so it can't connect directly to it. Okay? So that line should not be there. I'll erase it now. There we go. All right, so that's what you should have had for this particular one. So your assignment for today is really quick. It's not a very long assignment. It's 2 through 18 even. Won't take you long at all. And that's due before you leave today.